привет. У нас
Yes, hi everyone.
условно-обзорный доклад.
So here is the
Вы можете, наверное, в
general
какой-то степени
presentation where
расслабить свои мозги после
you
интересного
can relax a little
информационного
bit
доклада,
after a
которые
very
были
packed
до
day
нас.
with lots and lots of detailed
Собственно
presentations
говоря, вот
done by
speech
the
recognition
people before us.
security и
So speech recognition security and everything which
да,
is
про что мы
related
вообще
to it.
собираемся рассказать.
What are we going to speak about?
Собственно, что это вообще за технология,
What's this technology all about? How it works
используется,
and where it's
про
used?
ее, соответственно, security
So we'll
проблемы,
speak about security problems and
с девайсами,
bullet point by bullet point things related to security problems with devices,
и data privacy.
web cases, and data privacy.
И, собственно говоря, расскажем
We
про
can't do much about without data privacy.
и
How to
также
solve these
дадим
problems?
какой-то
That's what we're going to
небольшой
cover.
чек-лист, который вы можете
And we'll give you a checklist
speech recognition.
that you can utilize in your speech recognition
Что
projects,
это вообще
if any.
такое? Ну,
So
нам довольно такому
what's
примеру.
this? What the heck is
Когда у
this?
нас есть
I'm going to give you a simple example with the speaker
который что-то
yourself, for instance,
какую-нибудь, ну, например,
saying something
там
to a smart device,
включи там
a smart speaker.
свою любимую
Please put on my favorite musical group,
звук
like that.
колонку.
That sound goes to a smart speaker. Then some black magic occurs, of which we'll elaborate later.
Результат ваше
And there is a result of that black magic. Your favorite music starts playing from that speaker.
кейс
Of course, it's not the only case.
окружает нас в современном мире практически
We are surrounded with speech recognition elsewhere in many places. For example, if we get this Seryoga, a guy who is sitting in his home watching a TV with YouTube, smart TV with YouTube, and this YouTube is giving him some dynamic subtitles. They are used and created with the use of this speech recognition technology. Seryoga has a smart home
дом, подними мне температуру
where he
в
says,
квартире. Это тоже
please raise the temperature inside my room.
смарт-пин,
Seryoga also has this smart pin,
и
which he keeps here, and it puts
на язык
and
его
it gives the translation options from Russian to the language of his business partners from Bangladesh. We have a smart assistant of
И также у Сереги
the
есть
well-known manufacturer, and also Seryoga has a mobile phone which he used to talk to the bank
сначала проходил
manager.
биометрическую аутентификацию,
First of all, he was going through the biometric authentication with the speech recognition using his voice. And after that, he talked to call center. It was automated, and a speech recognition option was also used there. Okay, so
собственно говоря,
a little bit more detail about how it works. You'd say, dear device, how it works, and you ask about the weather forecast. What's the weather like today?
или speech-to-text.
Then it
Дальше
goes to the speech-to-text module. Then it goes to
NLP, в Natural Language
the
Processing,
NLP,
где уже происходят
where
некоторые процессы, которые мы тоже
some
покажем.
processes do occur.
Дальше, собственно говоря, происходит какая-то магия, результат отдает,
Then some magic happens, and
speech озвучивается вам
then
через
there's text-to-speech.
28 и вообще очень снег.
It's -28 in Moscow, quite snowy.
Ну, на
So
самом деле,
the weather forecast is on
первому
the screen,
пункту
it's there.
можно
So it
сказать,
seems like
это можно делать в том числе с помощью
you can do that also
Markov models.
with Markov
Начинается
modules.
это с того, что голосовой input
It starts with the voice input is separated into small time frames
дальше из
by 10 milliseconds.
таймфреймов
And these time frames
и спектрограммы выделяются какие-то акустические
have spectrogram of time frame,
голосовой input разделяется
and features of each frame
фичей и
are extracted. Out of these extracted features, we get
этот сет
speech
попадает в
set, and this speech set gets to the trained Gaussian mixture model, where it calculates probability of each phoneme for given extracted feature. This phoneme is taken, and then the probability of the phoneme A follows phoneme B to make sure that a word is made up of that, and then it repeats and repeats again over and over again till you reach the point when you end up with the text sequence, which looks more or less sound. And then you state the NLP model. It is even simpler. Your text is turned into token. Every word is turned into token, and then every word is separated, well, is defined by a certain type of speech. Then the dependency parsing starts. So every word is appointed with a certain role. Some word turns into a topic. Some of them are linking words. And after everything is labeled, entity extraction occurs. Entity being weather and attribute today. So we need to find out about the weather today. And then it's sent to the text-to-speech. Architecturally, there are two types of such things. That speech recognition that is starting at a device. For example, you say something into a device, some black magic occurs in there in the device, and then straight from that device, you're being given the answer. It's not sent anywhere. It all occurs locally. Or it's server-centric. When the speech goes to your device, then it goes to your data center. The data center processes that, and then there's text-to-speech with data from a server, or a combined version, which sometimes does happen as well. As with examples, it's quite obvious. Device-wise, there are smartphones, watches, car assistants, everything else. You can read that on the slide, whatnot. Device embedded in server centers are home automation systems. Sometimes they can process very simple commands on the devices, like, for example, raise the temperature, etc. And in some cases, this data is sent to the server and is processed there on the server. Igor, I think it's over to you. Yeah, thanks. I think we need to speak about security concerns. What risks may be there? Judging by how it works, we single out the main points. What is happening there with the signal processing, with the backend involved when it recognizes the speech. They try to utilize the backdoors. They may eavesdrop the speaker and record its data, record their speech, and do something bad with it later on. We can spoof, like Alexei said, in case of the bank, we can record this voice, and the recorded voice may be used for identification, biometric spoofing. As far as the web is concerned, it works, and actually works quite well even in this technology as well. So we'll start with number one. The bullet point is the signal processing attacks. In this particular slide, I'll show you the dolphin scheme, and it works like this. There are two logical
функционала, то есть это capture
functions here:
и speech
voice
recognition,
capturing and
когда у нас
speech recognition.
голос,
When we capture the voice,
ну, в принципе, как это, как и везде, то есть у нас есть там
everything works just like everywhere.
используемый сейчас во всех девайсах.
We use the MEMS microphone, we have the amplifier, we have a filter to cut off unnecessary frequencies, and
Стадия препроцессинга, на которой
analog to digital converter.
девайс в данном случае пытается понять вообще
This device tries to identify whether that
слово, да, которое
keyword was pronounced
ну, и
that
зависит от того,
leads to the activation, whether
девайс
that voice was
атаковать voice,
pronounced or not. Either you get this device activated,
например, там, не знаю, открыть дверь, там, закрыть,
you may
жарко, сделать холодно, выключить вентилятор, там, еще.
give instructions and commands, like, for example, turn on the fan,
Вот на данном слайде
increase the heat,
такие наиболее
etc.
известные атаки.
This slide shows the more frequent attacks. It has different manipulations with
Наш сигнал, да, наш input в девайс или колонку.
how this
Главное, наверное, отличие
device is functioning.
первых Нуита и Долфина от серфинга состоит в том, что серфинг
NUIT is different from dolphin and surfing. Surfing is not using premodulation, and this surfing attack is using legitimate commands that had been recorded some time ago. And we're trying to attack the speaker, and we reproduce the audible sounds audible to a human, to a person. So it can be tracked down and monitored. NUIT is different from dolphin, is that it uses ultrasonic frequencies that are above those that can be heard by human ears, whereas dolphin uses the recorded samples that can be intercepted in the course of spoofing attacks and translated into that range. In the first case, we attack with the non-audible commands for the human ear. Injection input is provided. In the second case, we take the text, we read it, record it, and then we translate it, potentially adding more commands to it. There are other attacks like lip read attack and slick logging, whatever. How do we mitigate it? The most obvious way to mitigate it is to filter and ignore the commands that somehow get into the speech that goes to the speaker. You may skip the parts that relate to the noise component, and the overall piece of advice to avoid the bugs is to regularly update and pitch signal processing firmware, because very often the program functions are added and the pre-modulated signals are cut off very often. So please do not ignore that. The next type of attack is the light command injection. As you can see it here on the slide, we can record some speech, and with the use of the app, we can translate this into a laser stream which affects the membrane of our speaker, thus sending commands in the non-audible frequency.
Скорее всего, в современных девайсах не прокатит, потому что вот те MEMS-микрофоны, да, которые мы рассматривали ранее, предусматривают установку нескольких микрофонов для усиления. Соответственно, в таком случае нам нужно...
It's not going to work in modern devices because they take multiple microphones. So we'll have to actually cast this stream onto multiple microphones at the same time.
Таким
There is this
через стекло
Tesla Model S hack.
в данном случае
Researchers, in this case, not attackers,
заинжектить
w-
команды, и у них
tried to inject commands, and they succeeded in doing so.
был кейс, когда
1 year after,
смог перехватить
there
управление
was a case where the researcher was able to take over controls of a drone,
голосом, ну и, собственно, также
which features voice controls.
посадить его.
So they were able to take over the controls and land
Тоже, наверное,
the drone.
очевидный совет, это как бы
On mitigation, the most obvious piece of advice
закрыть
is
там,
to try somehow to physically
или девайс от
mitigate
там, проникновения лазерного пучка. Ну, то есть, условно говоря, ну, это,
this
наверное, такое более
issue by preventing laser
ну, странно представить,
beams from hitting the speaker. But I can hardly
соседу
imagine someone
зачем, но в
attacking
целом, как бы, если
an Elisa smart speaker with a laser beam
совет
in real life.
физический барьер.
But the main piece of advice is to establish a physical barrier
Пытаться
that block light beams.
голос с нескольких микрофонов,
Next, you should try capturing voice from
когда вот
multiple microphones from a
колебания, которые
microphone array. This helps to counteract laser beam attacks.
класс, наверное, даже это
The next
voice skimmer.
type of attacks is a beautiful one, voice skimmers. It's pretty trivial in here.
Устройства, жучки,
Multiple recording devices, bugs,
они могут
etc.
аппаратные, да, там размещены
These can be both hardware
вот, там, говорящего
in close proximity to the speaker, in close proximity to the smart speaker and the person.
который мы атакуем, так и, собственно, быть залиты,
They can
например,
also
в качестве там бэкдора или там трояна,
be part of a backdoor, a Trojan software
позволяет
item on the back end.
модифицировать те данные, которые прилетают
This is a way to
в сервисы
take over,
основании речи. Ну, здесь мы
intercept, and transmit data. This diagram showcases a pretty simplistic case of a physical device.
так,
Regarding non-hacks,
была попытка взломать
there was an attempt to hack Amazon Echo in 2017. We can't say it was a complete success. However, the attackers were able to capture voice using a hardware device in close proximity to the speaker, to the person. It responded to the playback voice. The same applies to Google Home. It is the Google Home hack of 2018 and the voice assistant hijacking of 2019.
собственно, атаковали вот подобного рода девайсы колонки.
Within this scope, researchers attacked similar devices,
Как это было
and
сделано,
this highlights the cases they applied,
да, устройства в каких-то
where to put bugs,
внедряли прям
wiretapping devices. In
паяли
some cases,
там,
they
скиммер
soldered
уровня,
on
аппаратного обеспечения
a
колонки.
circuit board,
Просто там
an
запишешь,
integral circuit on the device. In some cases, it was just recorder,
говорят об успехе.
a bug, a recording devices. But this highlights that these attacks may be as well successful.
QR-коду можно сейчас перейти, почитать целый
You can
здоровый
scan this QR code on
глобально
VS mitigation.
сводится к тому, что нужно каким-то
What does it come down to globally?
чекнуть лайв.
Somehow we need to check the liveness
Мы обрабатываем в инпуте.
of what we process at the input stage.
То есть смысл в том, что тот
What is the point of it?
та дата, которую мы записываем, и
The voice we record, the data we record and then play back,
что мы произносим,
it will be different from what we produce with our vocal cords due to a variety of factors. For instance, external noise, vibration that we produce, and it goes on and on.
грамотно оценивать,
It all comes down to
скажем так, ну и
properly assessing the attack surface and the probability of such attacks.
пытаться этому
We
препятствовать.
need to somehow prevent this from happening and combat this.
Система, которая мешает активировать
There is a system that prevents
просмотре рекламы,
smart
например,
speakers from activation when you watch
на
advertisements.
рекламы, там совершенно
There were cases where smart speakers would respond to some words
спуфингу.
in advertising.
Представлены основные типы
We're gradually making the transition to biometric spoofing. These are the vectors of biometric spoofing. Impersonation,
в данном случае
these are physiological ones and behavioral ones.
Speech synthesis имеется в виду синтез речи.
Speech synthesis. This is speech synthesis, speech generation.
Markov model, например, WaveNet от Гугла.
We can use
Когда мы
hidden Markov model,
доступный нам информацию
GAN from Google, unit selection, USS. We can use available databases with pre-recorded voice
по алгоритмам
and speeches, which has been leaked. We can build a phrase which will sound legitimate
мы, собственно, используем различные
with the use of specific algorithms. Then we have voice conversion. We use various algorithms
реальным и так далее.
to make this voice sound more plausible, more realistic.
С записью в использовании смартфона.
And the classic replay cases like cut and paste using a smartphone. We put our smartphone with a voice recorder on somewhere.
Фразы там
When the target person, individual, says some code, words, and phrases which
условно в банке
can be used for banking or app authentication, we're trying to play it back, trying to overcome
кейсов можно
banking authentication.
который
Known hacks include Joseph Cox, who logged into his bank
таким образом попал в
account with AI voice.
банковский аккаунт. Ну, банк не помню сейчас, наверное, да.
I don't remember the bank's name.
Смысл был в том, что
It's hard to recall. But the point is that
Алексу
he used Alexa
скилл банковского, там, ну, интеграция с банковским аккаунтом,
that had banking integration installed.
в общем, модуляции, скажем так, речи.
He used speech generation, synthesis, and
Ну,
he was able to log in and perform some transactions.
наверное, тоже кейс.
How to mitigate?
Различные подходы для аутентификации.
You can combine speech recognition with another biometric system.
Использовать еще там
For instance, facial recognition, fingerprints, so you can use facial recognition in conjunction with fingerprints.
как я уже сказал, имплементировать liveness detection system.
As I said before, we can implement a liveness detection system. For example, void
Детекта, да, и там триггеров на различные
This includes detection
вот внешние
and triggers, which include
голос, то он будет
other factors like
нас кто-то пытается
external noise. If the synthesized voice is
комбинации, то
crystal clear, it is likely to be
фразу тем
artificially generated.
соответственно, провести как бы успешную атаку.
The more difficult a phrase is, the more complex a phrase is, the more difficult it is to perform a successful attack. Next up is backdoor exploitation.
Фантазия может разыграться и как бы
So we can give
бэкдоры можно рассуждать как вот
way to fantasy.
часть сюда
This can apply to the back-end part. We can upload something to the back-end. We can try soldering on additional integrated circuits onto the smart speaker. When we talk about backdoor exploitation in the field of SR, speech recognition, normally you talk about the model. We can break these down into attack mode, whether it's poisoned or non-poisoned. We can break them down by the adversary knowledge, whether it's a white box, when we have data sets available, where we can try and build our attack based on that. It can be a gray box or a black box, where we know nothing. The trigger type can be audio agnostic and audio specific. It means that in some cases, for instance, some devices, they require no voice activation. It is constantly listening, waiting for a command, so we can proceed with attack right away without any need for activation. In some cases, we need to say a combination of words or a phrase to trigger the smart speaker to keep working. We can attack over air or over line when we're trying to inject something, thus causing some abnormal behavior. This slide is about the timeline of attacks. This has been developed by Chinese-based researchers. It all started in 2017.
Ребят, он был в 23 году.
The last known
Глобально они
publication dates back to 2023.
в целом
They are beating around the bush,
идут про, ну, то есть
all of them.
в чем смысл вот этого
What's
развития,
the
да, то есть
point of this development?
вот с каждой новой итерацией там различных
With every new iteration of new attacks,
атаки к
the
то есть,
resilience
условно говоря,
of attacks to identification increases. That is,
современные, скажем так, подходы можно достичь того, что
by using modern approaches, you can make sure that
заложить троян так, что он будет
the Trojan attack
не
will not be detected.
мы можем также безопасно и там для нас
It can be triggered safely for us as well.
сделать это незаметно для пользователя.
It can be totally
Собственно,
invisible to the user. On backdoor mitigation, as already mentioned, we should do our best to detect and remove poison samples from the training dataset.
отравленных сэмплов в тренинг датасет, ну, например, как можно использовать там,
For example,
которая
we can use the strip technology,
определенные триггеры, которые
which generates specific triggers on its own, which may be potentially exploited by attackers. We need to train models in a way,
говоря о том, что
in the following way. These samples are malicious,
мешает дальнейшей
poisoned,
этого всего.
and then they hinder further exploitation this way.
Рекомендация, опять же,
There is also a standard recommendation, which
что это, в принципе, актуально
is about
в тех кейсах, где есть
checking inputs. Try to purify infected models
с ним что-то сделать, да, там как-то что-то заинжектить и так далее, и так далее.
and implement input pre-processing.
Да.
Next up, data privacy. Timofey, over to you.
Поговорить про датки, которые у
We-
нас используются.
I'd like to talk about the data used in
Помимо всего
speech
прочего, мы
recognition.
получаем кучу различной информации о себе к
We're sending lots of
и
personal data to the speech recognition provider,
наверное, сохранить, чтобы оно никуда не
and would love
ушло,
to
и
prevent this from
в целом,
being
что
leaked.
это.
And that's about it.
Собственно, о какой вообще датке мы говорим?
What kind of data are we talking about?
Команды, которые
It's
мы
the actual command data,
виртуальному ассистенту.
the commands we give to our so-called virtual assistant, the contextual data.
В том числе то, допустим, какой шум находится вокруг
This
вас,
data includes the noise class around you as you talk
в том
to your
числе
device.
какие-то сторонние разговоры, сторонние шумы и все такое.
These are some background noises and conversations. Yes, it gets captured and sometimes even is processed. This includes some biometric data.
С чем связана биометрия войса. То есть это
This is what voice
pitch, accent,
biometric data is related
ну, метадата
to,
это
like
вполне
tone,
понятно,
pitch,
все собирают
accent.
метадату. И
Metadata is pretty straightforward.
на самом
Everyone
деле
collects
errors, да,
metadata.
это тоже интересный пункт, потому что
There is
включается и
a pretty interesting point. Errors data. It includes misinterpretation, some
как будто бы не должны
ambiguous
обрабатываться,
speech,
но
which is
на самом
not
деле
supposed to be processed, but sometimes it does get processed,
Почему она
context
интересная?
errors,
Потому что
etc. What
она
makes
как будто
it
бы
this
не
point
должна
interesting?
представлять никакой ценности,
On the one hand,
но в
looks like
big
it's
data
supposed to have
всё
little value,
ценно,
but
поэтому
for
в
big
том числе
data,
это
everything
тоже
has
берёт,
value.
обрабатывается, и оттуда
This
тоже достаётся
one
данные,
also
которые
has
можно
value.
что-нибудь сделать.
It is used to pull data, and this data can be used to perform some actions.
Собственно говоря, стоит сказать, в чем плюсы и минусы сторинга и процессинга даты.
It's worth mentioning the cons and the pros of storing and processing. We have device-centric processing.
Повышенная приватность, потому что все данные
This
в целом
offers
остаются
greater privacy because all data stays on your own device, on the smart speaker. The data is processed
уменьшенная latency, ну,
where it is stored. It has
девайсе, оно,
reduced latency. Since it's all device
такие
processed, it doesn't go to any data centers.
вы даже можете использовать вашу
And sometimes you can even use your smart speaker offline with no internet connection. But unfortunately, these cases are increasingly rare. The cons are as follows: limited storage capacity,
идентификации вашего голоса, ну, потому что
worse recognition quality.
моделька, которая условно
That is
она может запускаться
because
в облаках на огромных.
the model you can run on the smart speaker is
в том числе
much more humble compared to those running on a huge cloud-based service.
и всякие
And you have risks of data loss. You can spill your coffee over your device, your smart speaker gets damaged, and you lose all of your data. Cloud ones. The classical advantages of clouds are as follows: improved quality of voice recognition, because they run
ваши данные
heavier
обычно
speech recognition models.
более в сохранности, так сказать.
Data is normally, I stress normally, is safer from loss because these are cloud systems of large corporations with respective security measures. Then scalability and accessibility, that's clear. Disadvantages. This approach requires internet connection to work, which is not always there. There are some privacy risks because your data may leak to someone you don't know. And in terms of costs, it is more expensive in such cases.
Какие вообще в целом есть такие баяны, связанные с обработкой?
Let's talk about the horrors
Ну, то, что вас могут условно заанонимить.
pertinent to speech recognition, that
С вашим голосом вы идентифицируетесь.
you can be identified with your voice. You may lose your anonymity. There are leakage risks from cloud service.
Службы за вами следят с помощью вот этих вот колонок.
Mass surveillance and data mining by secret services using smart speakers installed in your bedrooms. Your voice may get stolen and then used to log into your banking account and steal all of your money. Big tech bros may read your transcriptions, and the mic is always on. It's always on, it's always recording, it's always listening. These sometimes are not true. An SR, speech recognition provider, normally encrypts all of this data. Yes, data is encrypted. And there are some access control models. That is, not all employees can access this data, but sometimes it doesn't work this way as intended. Apart from that, speech recognition providers are subject to compliance regulations. So we're trying not to store what we are not allowed to use. These are the GDPR, HIPAA, the 152 federal law, etc., security awareness and data anonymization. So matching the data received with you is often very difficult. Normally, these companies are technically mature, they have regular security audits, they follow SSDLC, they perform constant monitoring and incident response, etc. There was a very major case where Amazon was subjected to a fine exceeding $30 million because their divisions associated with voice recognitions, they were using the data received through speech recognition incorrectly. In particular, thousands of Amazon employees were listening and transcribing private conversations of device owners. These were recorded using these devices. This is like minimum wages of $10 per hour, and they lost 30 million with that. Looks like they no longer care about that.
Да, ну и, собственно, в заключении всяких security проблем
They never get caught afterwards. Let's now take a look at the way this works for web services.
В общем виде, наверное, вот типичный workflow можно представить таким образом, что у нас
This is a general representation of workflows. We have a device,
наверное, не очень корректно выражаться девайсом.
or rather an operating system. It runs a browser. There is a web page with JavaScript.
Web-speech API, которая, собственно, реализует
It works with a web speech API with two key interfaces: local speech service and speech generation and speech recognition.
данного speech API
Using this speech API,
они транслируются
the
на
chunks
серверную
of
сторону,
our
где
voice
происходит
are
распознавание речи на
fed
обученных
to a
моделях,
server
и вот это
which
всё.
runs trained
Но в
models
некоторых
for
кейсах
voice recognition.
используется гибридная
But
модель,
in some
которая
cases, a
использует,
hybrid
например,
model
в
is used.
Windows есть
For instance,
локальный
Windows has
локальный сервис распознавания речи и
a local voice recognition
используется для того,
service.
чтобы там, в каких-то случаях проводить предобработку.
It is used for pre-processing. In some cases, it is used for recognition of some simple phrases. It speeds up the process, and it helps avoid transferring voice data over the network.
Следующим форматом есть, наверное,
Globally, it works
JSGF.
this way. GJS
Форматы SRGS.
GF is the founding father of all formats. Then there are some forks like sRGS, etc. The point is that there is a certain format used to systematize and describe potential phrases, the combination of words, their position in a sentence.
Распознавание речи мог преобразовать
All this is required for speech recognition engine to be able to transform the audio signals
распознать их в текст. Вот.
and convert them into a
Это примерно
text.
следующим образом.
It
На
looks
данном
like
слайде,
this.
самый примитивный снипет, который показывает, как это
This is one of the most primitive snippets.
какая-то грамматика, да, и там
There is some grammar being declared,
ну и, собственно,
hello
дальше можно
world
посмотреть, как это
example.
реализуется в коде.
And we can see the way it is implemented in code.
Да, используются всякие различные руles
As I mentioned already,
для простоты.
a variety of rules are used, but for the simplicity's sake, it's not there in this case.
Гибко производить описание
This
различных там
format allows for some flexible description of various patterns and
комбинации их фразы в предложении, в смысловые
word
предложения и так далее, и так далее.
recombination or word repositioning in the sentence.
В большинстве интерфейсов, которые мы с вами знаем.
And is used in most interfaces we know, including smartphones,
И прочим.
voice recording,
Работают вот
software,
распознавание речи.
etc., which implements a voice recognition technology.
Собственно, по багам, которые там содержатся, как
On bugs contained in these systems, as it follows from this slide,
технологии фазинга,
most bugs were found using a fuzzing technology. Most bugs are binary.
тот
This is caused by the following fact. The web speech API
браузера.
is a browser component.
Зачастую, найдя уязвимость в этом браузере,
When a vulnerability is identified in the browser,
осуществляется взаимодействие
since
с локальным сервисом,
web speech API is used to interact with a local service,
привилегиями,
which normally runs
кейсов, ну,
with
например, там,
increased privileges.
JavaScript sandbox, где-то даже выполнение кода.
There might be cases of JavaScript sandbox escaping and
Схематично, наверное, это можно представить так.
code
а,
execution in some cases. This,
какие-то
what a diagram may look like.
встроенные или вредоносные элементы на страницу, которые могут
There are
взаимодействовать.
potential malware items
Такие,
embedded in the page which can interact with JavaScript across website,
эксплуатацию
access things,
браузерном движке.
sandbox escape using the browser engine.
Который мы говорили в самом начале, который вот реализует
There
классические
is this OWASP top 10 we mentioned at the beginning of the presentation.
все в таком духе.
There is the server running a remote speech service,
Защищаться, ну, наверное,
etc.
общие советы такие, что
How do we protect from that?
за версии
General advice
браузеров
is
и компонентов,
to
которые они используют,
keep
если это критично,
updated the
то
browser
можно
version and the components they use on criticality. It might be critical
система распознавания
if we're using voice recognition for some day-to-day business practices.
которые
The typical business cases include the disabled individuals who are not able to enter text manually with their hands, so they have to use
текстом и так далее.
voice recognition,
Ну, обсек
speech-to-text technologies.
советовать юзать обсек, да, различные
So, being
проверки, аварийность,
an OPSEC person, I suggest that you use OPSEC.
наверное, более больше про API-шку, что как бы есть...
AppSec activities like SAST awareness, secure coding practices, and so on. Access control management. If we deal with user data, as Timofey pointed out, we need to implement data privacy, which is very important, and the way we access this data. Based on the bug
Фазинг говорила, как говорится.
slide, we need to use fuzzing.
Да, ну и,
So to say.
наверное, стоит упомянуть, что
It's worth mentioning
если вы крутой ресерчер,
that if you are a highly qualified researcher and you have made some research on bugs on web API or device-based bugs, you can always make some money with that. This buys you a coffee, or probably a nice house, real estate somewhere. There are two ways to do so. For instance, if you investigate a VK device, VK capsule, there is a bug bounty program which pays significant rewards, and another one on Yandex smart devices. I don't know how much they pay. Yes, thank you. It must be some significant amounts of money. So please enroll in these programs, and we'll be looking forward to your research results. As promised, there is a short SR security checklist. I would like to mention that this checklist applies to some generic cases, and it is dedicated to speech recognition specifically. So please feel free to take screenshots. Please make your systems safer and more secure. And now, having said that, congratulations, we made it. We made it to the end. And I'm thrilled to be able to gather here in this room at this venue. Thank you for listening.
Ура, ура!
Спасибо, ребят, большое.
Hip, hip, hooray.
У нас много вопросов.
Thank you, guys. We have lots of questions, but we're running out of time. So this is going to be a blitz
У нас есть вопросы для автопатии.
type Q&A.
По голосу, с какой
A question for an after party. Can you recognize alcohol intoxication through voice recognition? How can you establish the degree of drug intoxication or alcohol intoxication? The answer is yes, you can recognize alcohol intoxication by voice. Next question, which of the biometric system is the safest? Touch ID, Face ID, or voice identification? A combination of all. So, okay, we'll say Apple. We're going to text Apple. Have you tried using VI analysis for voice recognition? Wavelet analysis. Probably we tried to, but we're not going to cover that. That is going to be the topic of further conversations. Can you use neural networks to mimic a voice? Yes, you can. Yes, you can mimic a voice. So, for details, please approach our speakers on the sidelines of this meeting or check out the Telegram channel. Can you use LLM code injection, just like ASCII art injection? The short answer is yes, you can. Great. Next question. To protect privacy, can you relay embedding and not relay voice in its proper form? Yes, you can. For voice attacks, how do you provide for protection? The answer is yes, you can. The answer to all questions, yes, you can. How do you implement a test for liveness in the case of voice attacks, which are reproduced in the human ear frequency range? The liveness check is run in the following way. There is a set of characteristics in our speech which we're trying to identify whether liveness is there or not, whether there is any background noise or not, any noise or static. So the system analyzes multiple factors to verify samples for liveness. If you use offline models for voice recognition, so the competitors will have to implement this on a hardware basis, so it can be reverse engineered. How do you prevent this from happening apart from using compounds?
Okay, if there is an instance when the intruder is using somebody else's voice illegally was found guilty of committing this crime. Can we expect such precedents? Yes, we can expect such things to happen, but we have not had any public trials of such things. You guys were great. You just need to select 2 questions. There are 2 of you here. Please select the best question, each and every one of you. You decide. You decide. The fate is in your hands. I think there was a question about how to protect.
Вопрос, как защититься в офлайн-моделях, в принципе, прикольно был.
How to protect in offline models.
Да, и второй, наверное, вопрос
So,
про liveness detection,
and
наверное.
the second one
Liveness
was
detection.
about Linus detection. Linus detection. Okay. If those were your questions, do please come up here to pick up your merchandise as prizes. Don't forget that alcohol intoxication can be recognized in your voice. Thanks very much for joining us here today.